Plate Tectonics, an insider history of the modern theory of the Earth by Naomi Oreskes. Naomi, professor of history of science and an affiliated professor of Earth and planetary science at Harvard University, with a bachelor in mining geology from Royal School of Mines, Imperial College in London, and a PhD in geological research and history of science from Stanford University. As a historian of science, Naomi in this book examines the development of the scientific theories that led to our understanding of plate tectonics. And for someone like me who has always been fascinated by how tectonic plates move and how they got to the positions where they are today, her book shows a valuable insight into the history behind the scientific theories. But one of those early theories is the contraction theory, proposed in the early 19th century, suggesting that the Earth was once a molten ball and has ever since been cooling and contracting ever since. And as the interior cooled and shrank, the outer ridges of the crust would compress, which then created mountains. This theory was later rejected for many reasons. One being was the mountain age discrepancy, finding that a lot of the mountain ranges were not all the same age contracted. Another theory was the permanence theory, kind of similar to the contraction theory, but suggesting the continents had formed very early on in Earth's history rather than changing positions over time. And this one was also later rejected for a few reasons. One of it being they discovered C4 spreading. To the continental drift theory, which came after those two theories I mentioned, proposed by Alfred Wegener, a German meteorologist in geophysics from the 1880s to the 1930s or something like that. This theory was first presented in his book, which is in German, De Stuger des Kontinents und Ocean, in English, The Origins of the Continents and Ocean. And in this book is where he proposed the continental drift theory, suggesting that all the Earth's continents were once joined together as a single supercontinent, then later breaking away and moving into the current positions they are at today. His evidence, he suggested that North America, Europe, and Africa were all once connected, then breaking apart, including continents like South America and Africa, pointing out the rock layers in Brazil being similar to the rock layers in West Africa. Interesting to know that Wegener introduced the term Pangea for the single supercontinent, which is derived from the Greek, which is translated into English as all Earth. Another one of his evidence was the Appalachian Mountains in North America aligning with the mountains in Scotland. But the continental drift theory was not accepted by scientists when first introduced, that it may have been due to Alfred Wegener being an outsider, or that he was just a meteorologist and didn't really have a clear explanation of how the continents move. If I recall correctly, I think he suggested that the tidal forces of the water was moving the continents, but scientists quickly proved that force would be too weak to move the continents. Think about in the 20th century, technology was very limited. Maps were often incorrect, showing continents in shape and sizes. There was no satellite imagery. Scientists almost had no knowledge of what lay beneath the waters. Well, that would change with war. With the rejection of the continental drift theory, scientists still needed to find an explanation of how these continents move, how we got earthquakes, volcanoes, and mountains. In a section in their book called The New Age of Exploration, is this about World War II and the U.S. submarine warfare and how Americans suffered heavy losses in the beginning of the war. The Navy realized that geophysics and oceanography might provide means to detect and avoid German submarine U-boats. It wasn't until the end of the war that U.S. Navy saw the value of geophysical research, which then led to the establishment of ONR, the Office of Naval Research, which from 1945 to 1970 may have been the most exciting period in Earth history regarding to Earth science, as abundantly funding led to new age of scientific explorations, not to get across the ocean, but to spend time within the ocean. With new technologies like sonar revolutionized ocean floor mapping and produced better geological data. With this came new discoveries, like one of them being the mid-ocean ridges, a system of extensive chains of mountains and volcanoes in the world, which is underwater. The analogy that the National Oceanic Atmospheric Administration says, to think of it more like volcanoes that is wrapped around the globe, like the seams of a baseball. Another discovery was C4 spreading, with these mid-oceanic ridges occurring along what are divergent plate boundaries. And at these boundaries, these two tectonic plates will move away from each other or separate. As it separates, volcano eruptions happens, new molten magma rises up from the earth mantle. Once escaped, that magma cools down, hardens, and creating new oceanic crust, which is new seafloor. With these new discoveries came new theories. Near the end of part one, Naomi highlights like several key scientists like Harry Hess, who proposed seafloor spreading, Jay Wilson, who explained like the transform fault in California, and in the late 1960s, like Robert Parker, together with Dan McKenzie, who developed mathematical framework describing how tectonic plates move. Their combined work supported what became known as the plate tectonic theory, which Naomi describes as like a unifying theory of the earth science. Part one is more of like the historical context of how plate tectonics theory grew. But once you get to like part two to part five in the book, are like collections of essays by notable scientists who were like instrumental in developing the Earth history of plate tectonics, like writing their own firsthand accounts of their discoveries, theories. But more specifically, part five, from oceans to the continents, Naomi explains how scientists use new data to discover and understand earthquakes, volcanoes, and mountain buildings. She also notes that development of plate tectonics theory was a slow, challenging process, but today in the 21st century, geology is stronger than ever. Scientists can now measure real-time plate movement with the remarkable precision of space geodesy. There is still continuing research on plate tectonics, with funding expeditions may help scientists figure out more of what happens below the ocean. But my final thoughts of this book, if you're interested in plate tectonics and in the history of it, I highly recommend it, especially if you're looking to learn about like the scientists that played a role in the discoveries. It is about a 400-page book, and it is kind of pricey. This book gives readers who are not in the science field an insight of how theories and ideas in the science field can be developed, challenged, redefined, and ultimately accepted. Especially when it comes to plate tectonic theory. This theory gradually evolved over like 3 decades from when it was first introduced. When reading the essays by the scientists that played a role in the plate tectonic theories, it highlights like the human side of science, mistakes they made, like the debates they had with one another, the collaborations, and the breakthroughs, getting a true idea of like the theories developed over time. And sometimes these processes are often propelled forward by technology advancements that provide new tools for observations and like new data collection, ultimately helping to prove or disapprove a theory. But please share in the comments below whether you read this book or not and what your insights you gained from it. If you're planning on reading it, to support the channel, hit the like, subscribe, and check out the links below. Until next time.